Hi everyone. I welcome you all for this Tiva C series Launchpad Programming Workshop, Lab 5. So in this video, we are going to discuss about the Lab 5 programming with DAC. Right? As usual, we have that inbuilt DAC. Here, that inbuilt DAC, you have to connect. You have to find out here, right? This is one audio output jack, right? So here the DAC interfaced with the TM4C microcontroller through the I2C. I2C is nothing but inter-integrated circuit. So through I2C we have to connect the DAC. So let me go enter into the program. So this is the internal circuit diagram of DAC module. So this DAC module I already mentioned you the DAC connected through the audio output, the communication between microcontroller and then audio output through the I2C. So this is the I2C two electrical lines, that is serial data line and serial control line, serial clock line and serial data line. So this serial data line, serial control line connect, serial clock line connected to the port A and port A, PA6 and then PA7. So you have to use that pin number GPIO port A, pin 6 and pin 7. This pin 6 and pin 7, it is default, it is activated the I2C configure serial clock line and serial data line. So this is the programming step or algorithm for DAC. First you have to create the array of data for sine waveform generation. So the digital to analog conversion, first you have to create one table of data, right? The decimal data you have to create that, and then the DAC convert corresponding decimal data into analog waveform. So now we are going to create the decimal data set for sine waveform generation using sine waveform generation formula. I will show you. Then next step, you have to set the system control clock. You know, right? System control clock set. Using the syntax, you have to set the system clock. Then you have to enable the peripheral, that is PA6, PA7. So you have to enable the GPIO-A peripheral and I2C peripheral. Then you have to configure the I2C serial clock line and serial data line through PA6 and PA7 line. Then right, already you studied in the theory I2C concept. If you want to use that I2C have the two block, that is master and then slave. So whenever you have to send the data to the master, slave should be disabled. Then if you want to transfer the data to the slave, the master should be in the disabled position. So you have to call that master and slave to transfer the data through the serial clock line and then serial data line. For that we have to use that initialize I2C master, enable I2C master and get data to the I2C master. So these are the syntax used for this particular algorithm. Initialize I2C master, you have to use I2C master initialization external clock and I2C master enable and get data I2C master data put. These are the syntax we used. So here that is 8-bit DAC, 125 kilobits conversion rate. So 8-bit DAC is nothing but 256, but I'm going to use only 64 lookup table. That is 64 is nothing but maximum 127. So full scale voltage is 127, that is 0 to 63. So here I'm going to substitute 0, that full scale output voltages and consider 127, not in 256 samples are there, but here I'm going to use only 64 samples. In 64 means that maximum value is 127. So this is the formula we have to create the lookup table for sine wave generation. So n equal to 0 to 63. Here in this expression, you have to substitute the n value of n 0, 1, 2, 3, and so on up to 63. Suppose you have to substitute 0 here, full 0 plus 127, 127. That's why the first value is 127. Next you have to set that value, you have to send the value 1. So n equal to 1, 1 into 360 divided by 64 into full scale plus full scale, that is 127 plus 127, and sine of this value plus 127, you will get the values 139. You check it, you have to send the value n equal to 0, 1, 2, 3 up to 63. You have to get the data. Similarly, what is the data is nothing but for 0, right? 0 is nothing but what? Here it is the 0. For 0 means 127. This is the value is 127. From 127, it is increased by substituting 1, 2, 3, 4 like that, and it reached the maximum value 254. Maximum value 254. Then maximum it is right. Maximum it is 64. So you will get here you will get 32 means, so it is almost n equal to 15 or 16. You will get this maximum value. Then again you go to 17, 18 and all, it will be start to decrease and reach again 127. Reached again 127. Yes. Then again it going to decrease to 0, decrease to 0. Then again I go to increase, again it reached to 127, so maximum reach to 115. So this is the way this data set will generate the sine waveform. So you have to use this data set in your program. So as usual, you have to in your program you have to type a header file. So you have to enter two or three new header file here: system control.h, system tick.h, I2C.h, and you have to call the slave address 0x9f greater than 1, and call the delay, and use the void DAC decimal data unsigned integer value. So this is the value are used here. Already we created the lookup table for sine waveform. You have to take that table here and put it in your program. Then into main volatile unsigned integer I equal to 0, and you have to use that system control clock set. System control clock set, already you know this formula, you know this expression. So first I have to set the system control clock set, and the system control peripheral enable. System control peripheral enable I2C1, and system control peripheral enable GPIO-A. So this GPIO PA6 and PA7 you have to enable. So GPIO pin type I2C, GPIO port A base pin 6 and pin 7, and GPIO pin type I2C serial clock line is pin 6, and configure that. GPIO pin configure GPIO PA6 I2C1 serial clock, GPIO pin configure GPIO PA7 I2C1 serial data. So serial clock in PA6, serial data in PA7. Then I have to call that I2C master disable because I'm going to enable the slave. So call the disable of master. Then I have to enable the master by using I2C master. Initially you have to disable, then you have to enable the master. I2C master initially is external clock, I2C base 1 system control clock get false. You have to call the slave address here. So these are the common syntax used for I2C master and slave enable. Then I2C master enable, I2C C1 base. So I2C master data put I2C master base I2C one base equal to 44. Then you have to send the data, use I2C master command bus send start. And finally here you are using I2C master command bus send constant. So meanwhile, you have to use the data for I equal to 0, I less than 63, I plus plus, then 64 value. So for 0 to 0, 1, 2, 3, how to send into the master and then slave. That's why we are using DAC decimal data sign of 64 and decrement up to I less than 63, I plus plus start from 0. So this loop help you. You have to set the value. So you have to set the value I 0 to 63 by using this part of the program. Then you have to send the data to the master and then slave, and you have to stop that sending the data. So after you have to perform this program, you will get the sine wave like this. Then you have going to build the program in. Then we're going to type the program in the Code Composer Studio. So as usual, I already mentioned you right. No need to memorize and all what data will be entered into the inside, right? Just you have to type GPIO pin configure. You get it what you have to type into the bracket. Okay, for example, I will tell you Here I'm going to type I2C master initialize spin clock. And go to cursor here, you will get I2C master initialize experiment clock and as integer 32-bit base. What is the base? I2C 1 is the base, and unless integer 32-bit clock. So what the clock we are used? System control clock we used. So get the clock. So what is the boolean statement is false. You have to type that false, right? So this is the way you have to use what you have to type into that inside the bracket. First, you have to know that this is I2C master increase exponent clock syntax, I2C master enable syntax, I2C master data put syntax, I2C master control syntax. So these syntax you get this from the data sheet of the I2C of TM4C microcontroller. Then you have to type that syntax. You will get what you are going to enter into that bracket, right? So this is the easiest way to learn the program. Just but you must know that uh, syntax, right? But what conditions we have to enter into the bracket that will get from the helper, right? So once you have to type the program here, go to save and build. I think we don't get any error. Then go to debug. So after memory installation complete, go to run your program and check in your microcontroller board whether you'll get the sine waveform or not. So before that, you have to connect audio jack into the audio output of the microcontroller board. From the audio jack connected to the audio output, and next end of the audio jack, two wires, two wires, that is positive and negative wires. Positive wire connected to CRO positive, negative wire connected to CRO negative, you get that waveform. So I don't have a CRO to show you or show the output. So you will check, you will try, and you'll get that output in your microcontroller board and then CRO. Thank you.